This is one of my favorite logic projects of all time, logic problems of all time. So if you haven't solved it and you just wandered in here, I'd take some time to really think about it because I like this that you need multiple heuristics to solve it, unless you just go out and buy one of these and look at it. And makes you do some organization, some checking. So here's the problem. Suppose you want to make a desk calendar. You want to use two cubes to express each day with one digit on each cube. For example, on the 18th of the month, you'd have one cube with a side with 1 facing forward, another cube would have a side 8 facing forward. What numbers should be on each cube? Be sure to list the numbers for each block separately. Again, if you haven't done this yet, go do it. Take some time, think it out. I think there's some real gratification that can come from figuring this out. Okay, if you're here for the solution, or here because you're trying to figure out what you did wrong on your problem you turned in, let's see if we can figure this out together. So I'm going to do a few heuristics here. Let's start with an organized list of all the possible days we could need. Because whatever we pick for our cubes, we're going to need to be able to represent all of these. So notice we need to get all the way up to 31, but not 32 and thankfully not 33. So here are all the days we need. Now, if I just glance through this list, so they wandered far apart and then came back together here, I see that I need two ones. Right? I need a 1 on each cube for the 11th. I also need two 2s, so I need a 2 on each cube for the 22nd. So I know I've only got 2, 3, 4, 5, 6. I know you can't cut that out and fold that into a cube, but instead of going too crazy. Okay, we're already stuck with a 1 on both cube and a 2 on both cubes. Okay, just because of the 11th and the 22nd. Now, as you look over these days, notice if I have 0 on one cube, which I need, I can then get 0, 1, 0, 2, I could get 3, 4, 5, 6 maybe, but I can't get 7. I can't get up to 7 on this cube with a 0 in front of it because there's only 6 sides here. I've already got 2 of them taken up. So actually, from all of this, you have to have a 0 on both cubes. Okay, so let's fill in the rest of what we've got and see where we're at. So we've got 0, 1, 0, 2, 0, 0, 3, 0, 4, 0, 5, and then we also need 0, 6, 0, 7, 0, 8. Uh-oh. I feel like I can't get to 9. Right, we know we need these for 11, we know we need these for 22. We just figured out we need 0, 1 through 5, and then 0, 6, 7, 8 somewhere. So at this point, we can display every day except the 9s. So let's just make sure that's true. Okay, we just went through 0, 8. So 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. No 1, 9. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. No 9. 3, 0, 3, 1, and that's all I need. So the only thing we're missing here is a 9. Now, this is where the kind of clever thing comes in. We don't need a 9 because we have a 6. Since we don't need a 6 and a 9 at the same time, since this figure is either a 6 this way or a 9 upside down and we're moving the cubes around, we can use this to be both the 6 and the 9. So here's one solution to this problem. On the first cube have a 1, 2, 0, 6, 7, 8, and on the second cube have a 1, 2, 0, 3, 4, 5.